In this video, we will be learning how to solve quadratic equations for one of the variables. This is sometimes referred to as isolating a variable. When we're solving for a variable, we need to treat all of the other variables as if they were constants. Then we want to use the same steps we would use for solving any equation. So let's look at y equals 3x squared plus 7. If we want to solve this variable for x, first we've got to find where our x is. If there's x in more than one term, we have to look at it a little differently. But here our x is only in one term, and it's an x squared. So we want to use the process of solving by taking the square root on both sides and using our square root property. In order to use this method, our first step is to get the x squared by itself. In order to do that, first I need to subtract my 7 from both sides. So that gives me y minus 7 equals 3x squared. Then I need to divide by 3. So I have y minus 7 divided by 3 equals x squared. My next step is to take the positive and the negative square root on both sides of the equation. So this will leave me with x equals the positive or negative square root of y minus 7 over 3. You don't need to try to simplify these anymore. Just leave the answer in the form you get it in. In this case, the y minus 7 over 3 is under the radical. So x equals positive or negative square root of y minus 7 over 3. Let's look at another one. S equals 3/4 mk squared. This is similar to the last one in that the k we're solving for is a k squared in the original equation. So our first step is to isolate the k squared. We want to get k squared by itself. In order to do that, though, I need to take care of my fraction. I don't want to work with an equation that has fractions in it. So in order to get rid of my fraction, I'm going to multiply both sides of the equation by 4. That will leave me with 4s equals 3 mk squared. Now I still need to isolate the k squared. So because I have 3m times k squared, to undo that multiplication, I divide by 3m. So I divide by 3m on both sides of the equation. That leaves me with 4s over 3m equals k squared. Now once again, to undo my square, I'm going to take the square root on both sides. So I have the positive or negative square root of 4s over 3m equals k. Hopefully, this equation looks familiar to you. A squared plus b squared equals c squared is the Pythagorean theorem. But what we want to do here is get our b squared by itself. Get our b by itself, I'm sorry. In order to get the b by itself, we first have to get b squared by itself. So we will subtract the a squared from both sides. Remember, we want to treat all the other variables as if they were constants. So subtracting the a squared leaves us with just b squared on the first side of the equation and c squared minus a squared on the second side. These are different variables, so I can't collect them together. Now, since it's b squared, I want to get the b by itself, so I take the positive and the negative square root on both sides. So I get b is equal to the positive or negative square root of c squared minus a squared. One more. M plus 6x equals 5x squared. We want to solve this one for x. A little more complicated here because this time I have an x in the equation, but I also have an x squared in the equation. So if you think about what you would do with regular equations here, if it's quadratic, we have options of setting it equal to 0 and factoring it. I'm going to have a hard time factoring it, though, with this constant term being m. So square root property won't work like it did on the last ones. So we'll use the quadratic formula. In order to use the quadratic formula, we need to set it equal to 0. So I need to subtract the m, and I need to subtract the 6x from both sides of the equation to get it in standard form. That would give me 0 equals 5x squared minus 6x minus m. So now a is 5, b is negative 6, and c is negative m. It's not just a constant, it actually is the variable is included in that c. So we want to use our quadratic formula, so let me write it down. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now all I do is make my substitutions. If b is negative 6, the opposite of the negative 6 is positive 6. Then I have plus or minus the square root of negative 6 squared minus 4 times 5 times negative m. All of that is under the radical. And then my 2 times a is 2 times 5. So let's see if I can simplify that radical a little bit more. Negative 6 squared is 36. Negative 4 times 5 is negative 20. But when I multiply negative 20 by a negative m, I get plus 20m all over 10. And this would be sufficient to leave the expression in this form.